This conference will now be recorded.
All righty. So welcome everybody. Again, this is Don Mitchell and John Minash. We're with the Advanced Cooling Facilities Group. And for the past couple months, we've been working on the development of both reference designs and standards around liquid distribution in data centers. And basically the process of harmonizing, for those that are new to the call, we have OCP also has sub-projects that are looking at rear door heat exchangers and sub-projects looking at immersion and cold plate. And then we have a projects looking at the data center design. We're specifically focused on simplifying and standardizing the process of deploying liquids um, in data center facilities. And there's people on this call. I know that in the past, Dale Sarter, I see his name pop up, and Dale will say, we've been doing that for decades. What's changed, however, is in most cases, historically, when people were doing liquids, they planned it day one for the liquid distribution in their data center. And what we're finding is with the expansion and enhancement of liquid cooled application ITs and requirements, that more and more people are needing to design data centers with the ability to add liquid. And there's a different philosophy associated with adding versus initial construction. What I have here, generally speaking, if you're looking at data center design, there's always a mission critical foundation. And if you're adding liquid at day one, you can use a lot of processes in your initial construction that are not applicable and are very difficult to use in year three. For example, doing hot work is a common job site requirement at data centers at day before they're launched. Doing hot work in a data center after it's launched is not a recommended practice. It has done, but it's very high risk. Same thing with adding or tapping a pipe. It can be done. It is a high risk, generally costly procedure. And what we're looking at here is aligning the requirements of both mission critical and business requirements of data center at the same time. So people are doing things right now, and one of the people we're going to be hosting in a couple minutes, John Gross, is actually working on projects where they are integrating in an operating data center, and we're going to talk about that a little bit. But from the OCP's perspective, we're looking at trying to advance scalability. We're looking at being cost effective, and we're looking at things that are impacting the industry are some of our key tenets. And so that's what we're looking at. How can we achieve this mission critical goal and still be cost effective? So today what we're going to look at is some of the concepts around how to maximize reliability and cost effectiveness. And those can be competing terms. We were going to start looking at the leakage protection detection strategy, and we're going to come back to that as a second topic. But what we're looking at here is, where you don't make something fully bulletproof, or even when you do have fully proof, when do you spend the money and the investment to add extra protection and detection? That's going to be a discussion. We may put that toward the end of this. Tied into that ends up being, are there technologies today that haven't been around for 30 years or have not been advanced for 30 years that might reduce the risk factor or come up provide a better way to deploy liquids than what we're doing, and how can we take those best practices? And so we're going to look both. There's a term MTBF, and we're going to look at which is not normally a pipe term. And we'll talk about that in a little bit, but meantime between failure is typically used for electrical distribution solutions, and it's very commonly used for electrical distribution, but it's not been used historically for pipe solutions, but maybe it could be. And then the other aspect is prefab and how to specify that, and we're going to jump into a couple terms, and for those that aren't familiar with the term of level of determination, that, and is there a way that we could encourage the use of prefab? Would that actually reduce the risk of construction? Would it reduce the risk of operation? And actually, I'm going to jump to that topic first because one of the best speakers we have on that is John Gross. And John, have I given you a handoff that you can run with, or where do you want to go with?
Well, so I think I think that's a good handoff, and we can go to that here. So one of the big things that we're talking about in terms of the prefab discussion is, to Don's early point, what are some of the things that can be done to minimize hot work in the space, and also maximize the quality. So when you're talking about piping prefab and whatnot, one of the advantages that offsite prefab gives you is better quality control for welded solutions. For example, you can do your testing at the fab shop to test your welds there. In addition to that, if you're doing a welded solution, they can rotate the pipe on fixtures so that the welder is at an optimum working position the entire time the welder is laying bead. So that just improves the quality and the consistency of the welds and whatnot. The big issue becomes in an existing facility, what are some of the technologies and the techniques that can be leveraged in order to maximize the amount of prefab that can be done? And I think one of the things that I've experienced personally is no matter how hard we try, no matter what technologies we use or how good we are at it, there really is no such thing in practicality as perfect prefab. You can get close. And so part of the goal is to figure out, what stuff can be prefab, what stuff is going to have to be field measured and done locally. One of the technologies that I have used in projects in order to improve and maximize the amount of prefab that the construction team can do is the use of LiDAR scanning of existing conditions. For those of you who are not familiar, LiDAR scanning is also called laser scanning. It's basically using specialty cameras that can take 3D images of an environment and the elements in that environment and convert that 3D image into content that can be used in design or coordination models such as Revit, Navisworks, etc. So I've got an example that I want to show that Don and I talked about of a project where I did some LiDAR scanning so that we could do some offsite prefab. Don, if I can grab the screen.
So I stopped sharing. Does that mean you can?
No, you have to give me, you have to set me up as a presenter, and then from there I can share.
Now I'm learning something new. How to,
I believe if you right click on my tile there, you can make me a presenter.
Yeah, if you right click on the hamburger menu in the upper right, down, you should have a list of options.
Hamburger menu.
Yeah, sorry, on the top of each person's tile,
Oh, okay.
Here's a tiny little menu. Yeah.
Yeah, so make presenter. Got it. Sorry about that.
No worries.
John,
that wasn't very good. I wasn't coaching very good on that. Sorry about that, man.
Okay, so the LiDAR camera that I use in my engineering practice, and most of the cameras do this as well, is they will actually take a series of HDR photographs, and then they will also do a laser scan. So this is one photograph that was taken by the camera of a particular part of a chiller plant that I was doing some scanning and some as-builting in. And this was a project where during construction, there were a number of major changes made to the piping configuration relative to the design. and the as-built were never turned over to the owner, and the contractor can't find them. So we had a large chiller plant that didn't really or was not well documented, and so we didn't know where things actually ended up. So this is what you see when you walk into the space. This is a picture that you would take if you're out there as an engineer or a contractor trying to figure out what goes where and how everything is related, and this would be your perspective. And as you can see here, I can look up and I can kind of pan around and I can see different spaces, but I can't really improve my view from this location. So the 3D camera actually goes and scans the space, and each one of these pixels that you see contains distance and color information in that point from the location where the camera was set up. And each one of these circles that you see here represents a location where the camera was sitting, okay? And the camera on average takes approximately 70 to 80 million data points for every camera location scan that is performed. This particular project had 163 scans in it, so the total file literally has billions of data points in it. And from here, some of the things that you can do is now I can actually, in this 3D model, this point cloud model, I can actually come up here and I can see elevations and I can see relationships in the piping arrangement. I can see flanges and flow meters and whatnot that I couldn't see necessarily from the floor very easily. And this is all really handy for understanding, what's going on in the space, but that's only part of the solution. The next step is I can take all the content that's in this and I can now convert it into a Revit model. I will say there is definitely a process to get it from the point cloud to the Revit model, but once I get it into the Revit model, I can now have my manual valves, I can have my strainers and so on and so forth. And this particular camera that I use for my practice at a distance of 60 meters is accurate to 1/4 of an inch. So you can get very high levels of precision if you follow the best practices for setting up the camera, operating the camera, etc. You get very high levels of precision taking this. And from an engineering standpoint, I can take this and I can convert it into a Revit model. I can do my design work in a Revit model. And people historically will say, well, that's great, you've designed it in Revit, the contractor is going to go build something and they've got to draw it on their own and do all this other stuff. So the Revit model is helpful, but it only kind of does so much. That used to be the case. Historically, up until a couple years ago, Autodesk had a series of plugins that they made available in AutoCAD 3D, which would allow them to generate spooling drawings off of piping, generate coil line drawings off of ductwork, and so on and so forth. But they didn't have that for Revit. Well, they do now, and it's actually a process called fabrication part. And on a project recently that I did, where I was hired by the contractor actually to do the layout for a chiller skid and pump skid and so on and so forth, but they wanted me to actually model the piping such that they could fabricate off of it. And so what we did is we modeled all the piping and then we used the fabrication parts. And the fabrication parts within Revit actually will go and pull in libraries of ANSI standard and ASME standard dimension parts. So your long radius 90s, your short radius 90s, the ODs, the IDs, the bend radii, all of those things come straight out of the ANSI standards for these parts. And so what you end up with is a situation where now my pipe has not only a standard long radius L, it also has a weld neck, has the weld neck flange on it. has the butterfly valve, and these are all ANSI standard dimension parts. And in addition to that, these thick lines that you actually see here at these joints, that's a welded joint in the field. The Revit will actually put in there the gap that ASME recommends be used for making this weld. So at the end of the day, I can go and I can create a spooling drawing, which takes this particular spool, has my flange, has my elbows, my straights, my weldolets for my thermal wells, and or threadolets for the thermal wells, and for the air vents and the drain pipes and all this other stuff. And these thick lines are actually gaps so that this pipe and this elbow are the correct dimensions, so that this center line dimension to this center line dimension accounts for the ASME recommended gaps for performing these welds. And the software will actually spit out a bill of materials that tells me how long this pipe is, what spec it is it A53 black steel, so on and so forth. It'll give me counts of different sizes of weldolets, threadolets, so on and so forth, so that I can actually create fabrication drawings straight out of Revit. And this really helps us move towards that discussion of being able to do offsite prefab, shop fabbing, shop examining welded pipe systems like this, recognizing, and this is a key part of the discussion, recognizing that riggers are good, and riggers can usually get this chiller and this pipe or pump skid assembly in almost the perfect spot, but there's going to be variations in the field, how the concrete's poured, how level it is, so on and so forth. And so what we do, and I've not yet done it on this particular set of drawings, which aren't quite yet due to the client, but we're actually going to make this a flanged connection right here, because we can get a bunch of stuff prefab, recognizing that this little section of pipe should probably be field measured and fabricated. So this is kind of part of the discussion of things that we can do in order to help improve that offsite prefab, how much we can do on it, how much we can actually add to the quality of the work. The LiDAR scanning is something that not many consultants do, but a lot of contractors can do. So even from the standpoint of a project delivery, if you have an engineering consultant that doesn't do LiDAR scanning, they can still do modeling off of something that's pretty close, and you can specify on your project that the shop and fabrication drawings that are being produced for the actual fabrication of the piping system have to be created using a LiDAR scan of the existing conditions as the basis for identifying your points and locating your points of connection to the existing piping network.
So I like that little comment there, and it actually kind of ties in. Fantastic. And I don't mean to cut you off, John. If I was just mesmerized with your presentation so far. But you kind of hit the last thing you said was things that we could recommend or that OCP might want to include in this discussion or going forward. Let's drop back to the term of LiDAR and the use of LiDAR. Going forward, BIM isn't a technology, it's more of a process, correct? And so if you've started out your data center with a BIM foundation and you've maintained it, do you still need LiDAR to, or would in theory you be able to add just based on your discipline around your existing as-builts?
So the way I've done it historically is, and part of this is a recognition of where our industry is. So right now, our industry uses Revit modeling, 3D modeling with some level of information in that I part of BIM, right? There's some level of information in there in order to generate construction drawings and get them out in the field. In my experience, it is extraordinarily rare that owners are willing to pay the consultant to as-built that Revit model at the end of the project. It happens, but it's rare. Frequently, owners believe that if they get a 3D Navisworks model from the contractor at the end of the project, that's their as-built, that is the same thing as builting their model. You know, it's not like in the past where, as an engineer, I could hand off a set of CAD files to the contractor. The contractor's detailers can go in there and they can modify the CAD files and kick them back over, and boom, there you've got as-built. If I go and I give a Revit model to a contractor, and the contractor turns around and they do all their fabrication work and they do all their as-builting work in a separate software platform, that information can't simply be reopened in Revit and boom, you have as-built. There is a process there to align what has been done in the field with Revit. So on projects where I've done LiDAR scanning where an existing Revit model exists, what we do is we take that existing Revit model and we identify those interface points that are captured with the LiDAR scan, and we make adjustments to those points of connection in the Revit model to make sure that that is as-built correctly, and then we can go from there. A lot of my LiDAR projects, honestly, however, have been projects where either there was no 3D model created to begin with, or there was, but we know that there's a lot of inaccuracies in it, or the owner just simply doesn't have drawings and we've got to figure it out from scratch.
So what recommendations? I mean, a lot of what we're talking about is stuff that's really been developed mostly in the last 5 years. Before we jump topic too much further, the term LOD is something I didn't know how to spell LOD 3 years ago. Now I'm using it frequently in discussions with people. Does it apply to your discussions here?
It does. So if I go back to, for example, this project here. So on this particular project, the owner did want to have the Revit model accurate to where the schematics were and the points of connection. They weren't necessarily concerned with whether or not this valve, for example, was exactly dimensionally correct for a class 150 valve, right? That wasn't a big concern of theirs. And so this is a valve that comes from a manufacturer. Theoretically, it should be dimensionally accurate, but you know, we're not 100% sure if it is or not. When you get into the fabrication parts piece, now you're starting to talk about Revit families where dimensionally everything in that family is, all the critical dimensions are accurate to the ANSI standard. So if it's a class 125 or a class 150 valve, then it's going to have the flange patterns and the thicknesses of the body assembly and all those things, so that your spacing between your flanges for this valve to sit are actually correct. LOD 300 is typically a situation where you've got the pipe routing correct, you're demonstrating the major equipment as dimensionally accurate for the overall shape and size, the points of connection, so on and so forth. But a lot of times things like your piping ODs, the materials of piping, is it copper, is it schedule 40 black steel, is it standard weight black steel, so on and so forth. That stuff really kind of stops at 300. When you get to 350, that's when you start saying, okay, if this is a black steel pipe, I've got to have it modeled as A53 black steel pipe so that I've got the correct IDs, ODs, etc. My flanges are all correct, so that if I say it's a class 150 flange, it's a class 150 flange dimension, and I cannot connect a class 150 flange to a class 300 flange. It doesn't work. You know, those are the additional types of information that you see in an LOD 350 model that you don't see in the lower LODs. And historically, on the design side, we've stopped at, from the engineering standpoint, we've stopped at an LOD 300. We hand it off to the contractor. They take it to an LOD 350 so that they can do all their spooling and fabrication shops and stuff like that, hangar locations and so on.
So jumping around a little bit. Number one, LOD, what is that? Level of detail or level of determination or something like that?
Level of development.
Development. Okay. So you got level of development. And once you start talking 350, you're talking an accuracy of about how fine an accuracy if you were looking at a component?
That's hard to say, and the AIA is actually not defined what the dimensional accuracy of that is. What they basically say is once you get to LOD 350, you are at fabrication level accuracies. And that's kind of the generic term that they use. LOD 300 is not considered fabrication level accuracy in terms of location and routing of piping, conduit, ductwork, et cetera, and the dimensions of the hardware.
And is there a relationship between LOD and ANSI in terms of, so you have an ANSI specification for valve dimensions? Is LOD 350 aligned with that or what?
So the component libraries that end up in the software that are supposed to be the fabrication parts, the LOD 350 parts, use the dimensions out of the ANSI standard documents for that component.
I just want to, this is John, I'm going to just add a comment, and I think why I think this is all applicable to our subgroup in particular. If you're a user and you're going to try to connect into your existing chilled water system, and you want to minimize the amount of work that's done, that's especially hot work on the site, having a lot of this prefabbed is a way to minimize that interaction on site and reduce your risk. So level 350 brings you to the level where you can have that done. And John's mentioned the term a few times, spools. If you're not familiar with piping design, a spool is a yeah, John, there you go. So you can have these built off-site. You can have them built off-site and tested and done, and the final connections might need to be a flange connection, but it might need to be also a weld or a grooved connection. But the point is, you can have some of this work done off-site. A distribution header, a connection into a chilled water system can be done as a spool or a prefabbed piece off-site. So just wanted to mention that.
Unfortunately, I think we're about to lose John. Is that a fair statement, John?
Yeah, I've got to drop off here in a minute, so I apologize for that.
Okay, I meant John Gross, not John Minash.
Yeah.
So we'll let you go to your obligation. I guess one thing I would like to throw out to people on the call, is there anyone on the operational side of data centers or systems engineering side of the data center that would like to comment about what we just ran through? Is this something that you're contemplating? I could pick names if I needed to, but do we have any systems engineer? Go ahead.
Yeah, this is fantastic. I mean, how much technology has moved over the last 5-10 years. This is great. A lot of that documentation is missing. I assume that this can also be expanded to include the piping over the white space or near the white space where those connections might be having to be made.
Yes, absolutely.
Yeah, Jason, that's what I was actually thinking. That's what, for our particular group, John's showing a plant, but the connection point to the building is going to be important for a lot of the users here. Sorry.
Yeah.
John.
And just for the sake of clarity, the main reason why I showed a plant instead of a data center environment is just because my data center clients won't let me show their projects.
Right. Okay. Yeah. Understood. Just adding this to our toolbox would really help customers, come at ease with retrofitting and bringing water into the white space.
Well, I appreciate that insight, and I guess one of the things we're looking at is, going forward versus what's happened in the past. Most of the people that have data centers right now, hopefully they put in some sort of contingency, but we're trying to figure out how to make it. What should we provide as guidance from OCP? I mean, not everyone to align with this. How can we define? And I'm not sure we're going to achieve that today, but you kind of see where we're going. Some things. John, I'm assuming you're dropping off, and I'm going to take over the screen again, if that's okay.
Yeah, that's fine. The one thing that I would say before I do drop off is that I think, Don, you and I had the conversation the other day, and I think this is a key thing for us to keep in mind as we go forward in this effort, is that there are really two parts to, what we're talking about here, in terms of the overall effort. Some of it is trying to identify what we think as an OCP working group people need to do in order to be a quote unquote OCP ready for liquid cooling or OCP compliant. And then there's a whole separate set of things that we're talking about here that really are guidance on best practices to minimize risk and and ensure ensure success of your project. And what we're talking about here, specifically with LiDAR, BIM modeling to LOD 350, offsite prefab, so on and so forth. That's not an OCP thing. It's not even really just a liquid cooled thing, but it is something that can be done as recommended guidance of, hey, make sure you're aware that this technology, these practices are out there. There are people that are doing this. It's not, just the fringes of the market that are doing this type of stuff. And, if you as an owner, want to minimize your risk, you can write it into your RFPs and your contracts that these types of technologies have to be leveraged in order to help you minimize your risk. And that's kind of a, hey, we've got people here that are talking about it and doing it. That's really, again, not specific to OCP. So let's just at least get the information out there as an opportunity.
Okay. Hey, John Gross, greatly appreciate that. I really don't want to get your kids suspended from school if you're not at the call.
Okay, I appreciate it. I'll talk to you soon.
But Jason, also appreciate your insights. And one thing I would also like to throw in real quick, it's not just an issue of hot work or the issue of construction inside an operating data center. Has a huge overhead to it. And I don't know if in terms of whether or not you have to have a security guard watching the guy who's doing the maintenance, and especially in today's world. Jason, you got anything more on that? Or is, because we're going to go on to a couple other topics real quick, but any insights real quick?
The only other thing I'd say is it'd be nice to be able to have a tabulated table showing the performance we could get out of different operating conditions, much like we do with perforated tiles. We get a 25% perforated tile, and we know how much cooling that can deliver. Same thing with any percentage perforated tile. If we could do something like that and simplify it for facility loops, that'd be very beneficial.
And that's exactly we're going to be covering next week also. So we're kind of alternating back and forth on the topic theme to give us. So last week we did something looking at reference designs, and we started developing that table that you just discussed. Next week we'll probably be showing that a little more depth on that. Today we're just talking about technologies to get people beyond the fear and cost of liquids. How do we reduce the cost impact of adding and the fear impact of adding liquid to a data center? So we just kind of covered, going back to where we started on this, we're looking at this concept of, let's go back to the beginning. And so we're looking at, how can we get mission critical and still meet your business requirements? There are ways to be mission critical that cost a lot. But one of the things we're talking about here just was the concept of, precision prefab, how to specify. And that's something, whether or not we specify it as an OCP ready or compliant aspect, or whether or not we just list that as a recommendation. The concept of BIM LOD 350 is generally what is being constructed. And then the debate between ANSI versus, you can actually, a large number of vendors now have all their products modeled in a BIM format so you can drop it in with a LOD 400 level of accuracy. And the reality ends up being, by having your components all accurate to say 1/100 of an inch, makes it easier to have your design accurate to an LOD 350 or your construction aspect, and also reduces the amount of the issues when someone has a last minute change. This is kind of what I think, Jason, you were talking about this in terms of can we model, or should we be looking at modeling of pipes over the rack? These are a couple different models. This is one we derived. This is one that was sent in by one of the participants on this call, and just looking at where you can go. And I kind of, this point I'd like to look at as we look at this, where would you put leak detection and where would you put leak protection on these kind of devices? What thought process goes through that? Anyone contribute on that?
Don, this is Adam. I can give you some input on what we did on the detail there on the right-hand side. Because it was an overhead distribution system, we actually put a clear plexiglass drip tray underneath the piping manifolds. So clear so that when our operators walk under, they can look up and see if there's any little puddles of water, any pinhole drips or anything that are happening. And then we actually used rope leak detection and snaked it through that drip tray, and then tied that back into our BMS for alarming in the event that any water did fall in that drip tray.
Okay. Now, if you'd had a solid piece of pipe going through your data center that was going from one point to another point, would you do the same level of, I mean, if you didn't, I mean, it was just one solid segment of pipe, would you feel a need to put leak detection and protection on that?
I would weigh against my dew point in the data hall and the water temperature in the pipe, but in general, no. We looked at this being our issue, that human error with all the valves was going to be our highest risk of a possible leak. And so that's why we protected it here with all of our valves and our connection points.
Makes a lot of sense. The only reason for kind of talking about this is try to bring it out a little in terms of, so recommendations along the lines of leak detection and leak protection would lead more toward what you just said. If there's a valve present, if there's something that's going to be disconnected on a frequent basis or connected on a frequent basis, you definitely want to have some sort of provision. And the next question ends up being, is there a volume discussion here? I mean, if you disconnect one of those rear door heat exchangers, how do you accommodate the amount of water that may drain, or what do you do to make that safe?
So in the case of this, every point of connection up on the manifold should have an isolation valve so that anybody going up there would isolate the 1-inch feeder or whatever's going to feed the active rear door or whatever you're going to. In the case of the active rear doors, almost every one of them that I have seen, I can't think of one that doesn't, has some kind of Schroeder valve or something at the low point of the coil so that you can actually drain down those coils.
Okay.
When you need to take them down for maintenance, or if you need to drain them.
And so just kind of putting that in, so you kind of accommodate that you're going to be able to drain and so the other question kind of as you look at this is, you know, everywhere you put a valve, and whenever possible, putting a valve in a place that can, if it does need maintenance, it can be done so properly.
Yeah, and can I add one thing real quick, Don? I guess on the leak detection and your prevention comment, you have to, we weighed the risk of what are we trying to protect? Are we trying to protect of a small, a valve not seating very well, or a handle, or a small little bump, or a pinhole drip? We were not trying, we mitigated or didn't believe our risk was a ruptured pipe or a 2-inch header rupturing and flowing high level of GPM. That wasn't the risk we were trying to mitigate. It was more a small incidental or a spray or a drip that could happen versus catastrophic failure.
Okay. Interesting point. So trying to quantify how that all comes into play. Just one thing real quick as we start talking about things like the LOD. This BIM and LOD concept basically didn't really get codified or established until like 2011, 2013. So it's not a ancient concept. But back to what you're saying on where do you determine your risk factors? Let's see if I can find something to talk about. One of the questions I had, how do we determine what's a risk factor and things of that nature? And so you have terms like MTBF, mean time between failure, warranty. We talked about that in the past. Just out of curiosity, what do you ever use? I'll keep picking on Adam because he stepped up here. Do these terms ever get used in how you apply designs or things of that nature?
Honestly, not from my standpoint, no. Because we usually look at human error as being our biggest factor, and we try and mitigate around our human error. So we don't necessarily look at, so take a CDU as an example. I wouldn't worry about a CDU in terms of that, because how I would mitigate that is we would put some kind of rope leak direct detection around the CDU that ties into either the CDU's HMI, that if there was a leak, it would shut valves or it would do something internally, or we would tie it back to our BMS so we can go investigate it immediately. Same thing with valves or anything else that we're protecting. We feel that our biggest risk is if an active rear door has an actuator up on the valve or up on our header, any kind of maintenance repair or anything to a failed actuator has the risk of somebody being on a ladder overhead and losing their balance or bumping into another valve or something else. So we just kind of try and simplify it down from a human element, not so much mean time between failures.
Hey, Don, this is Dale. I wanted to agree with Adam regarding the priority in terms of the leaks, although I don't think that the major leak should be forgotten. I guess the point is that you want to limit the volume of water that could potentially come out of a major leak, so that you know, I mean, you see these stories on the news where somebody runs over a fire hydrant and, you know, it takes them 2 hours to shut it off. And, you know, we don't want that in a data center. So if the system has an automatic makeup system, it becomes more critical that you think about what happens if there's a major leak. But if you solve that problem, I agree that the higher priority are the smaller leaks.
And Dale, to feed into that, so what we ended up doing on our overhead drip trays that we did is we ran a 2-inch copper gravity drain to a wall, to a clean out, to a sanitary store in that event as the what if. But what we didn't do is we didn't calc it backwards, looking at what is the capacity of a gravity fed from a 2-inch drain, or if we had a rupture, could we contain all the rupture at the head pressure coming out of that pipe with the possible flow rate, you know, to create a box around it to force everything into the drain. We didn't go to that level of detail.
Yeah,
but we did put a 2-inch drain on it to sanitary.
So that's one discussion also associated with heat exchangers, okay? Because heat exchangers by definition will reduce the volume of water that can actually go down to the next loop, okay? Heat exchangers have a negative of basically your approach temperature and you lose efficiency of your data center. I would say that I'm not sure I'm hearing from this audience, maybe we're all in favor of liquids, but I am hearing from some people in the industry where a much higher level of stress and concern is applied, not just to what is more likely, as in people breaking something versus something breaking on its own, but the perception that any pipe in a data center is a risk factor is a challenge. And Dale, I know you kind of started to talk to that. Let me go back to one discussion on mean time between failure. Mean time between failure is used a lot in electrical solutions. It's not hardly used at all in pipe solutions. Any idea why that is? Well, to a large extent, it's because MTBF is not defined for craft work. So if it's an art-based project, if it's not something you can do 1,000 times or 10,000 times repetitively, that's one challenge it has. So where I go with this is one thing that's happening in this prefab world is things like welds. Historically, welds were not really applicable for mean time between failure analysis. But when you put an automated weld process in place and you do the same thing over and over again, you actually can develop MTBF. It may be something that the industry should be looking at more in the future. With coupling technologies, that's something we have looked with coupling technologies. Coupling technologies have gotten to the point now where billions of hours of coupling base, you can predict MTBFs. Basically, if it's a properly designed coupling, you can define it with a visual inspection process that will guarantee no leaks. How to make people comfortable with this is an interesting challenge. Any thoughts on that?
Well, Don, I mean, I think you mentioned lots of experience, and then you mentioned before if installed correctly, and just now you said if inspected and if designed correctly. Those are all human errors. So I think that what you're saying and what Adam was saying was the same. You had a lot of ifs or a lot of caveats before you were able to state that you could develop a mean time to failure.
So let me clarify those caveats. If any vendor of any product is able to substantiate an MTBF and an inspection process that is visual, should we include that or request that? Dale? Hello, Dale.
I didn't realize that was a question for me. I thought it was a general question. I would say that is up to the design team and the owner to decide, cost benefit of that, and what their own capabilities are their comfort level with their own capabilities.
So the interesting challenge.
The other point is, Don, the MTBF data in the mechanical world is so limited, right? That typically you're not going to have enough really valid MTBF data to really look at it as a system level. And so I don't know that there's a lot of value unless you had everybody that you could look at it at a system level. I don't know, that gets kind of a little bit of a study for the sake of a study, maybe, if you're not careful. What I would propose though is recommending and giving guidance on failure mode effect analysis, right? Now, I think there where we could give people guidance to rank the probability, the severity, and what containment strategies they have in place, right? And that might be more valuable than trying to give some MTBF guidance that you may or may not have enough data coming from industry to do anything meaningful.
It's something I may want to talk with you offline, because it sounds like there's a whole lot to expand on from what you just said there. So let's kind of go back to what I'm trying to do is figure out, are there methods to minimize use of this or maximize use of leak detection strategy where it's needed and minimize where it isn't? Okay, try to come up with methods that would reduce the cost and reduce the potential of any kind of leakage during an operating data center. We only got a couple minutes left. Any other thoughtful discussions on this? I mean, does anyone else want to talk about either MTBF? The question on warranty kind of came up. I mean, how do you determine the replacement frequency of a valve?
So, Don, this is John Musilli, a former Intel engineer.
Hey, John.
How you doing? So what we did, we had to deal with this with water inside our data centers, and we had some very high volumes of water. We were running upwards of 16,000 GPM through some of our rooms overhead for some close couple cooling solutions. And so we wrestled with this, and two things we discovered. One, it's the small leak that was bigger concern, because small leak leads to a bigger or more catastrophic event. But the most likely event was a drip or a spray event. And so one way we thought we'd mitigate that is to diaper that joint or that valve, and then just put a leak detecting sensor in that, just some moisture sensor in that, and that would be a relatively simple solution. And we actually decided not to do that. And because we did this further analysis that all our water was in the hot aisle, and that that spray or leak would actually not impact our servers or our compute devices for the most part, because it's going to spray into the hot aisle and can be found on the floor and or felt walking by it. So we abandoned the diaper, but it was a clear solution if you had a really critical path to put a diaper around the valve and just put the sensor in that. The thing we did do from a reliability standpoint was we required all of our piping systems and coil systems and customized designs to be tested at 3 times design pressure at the factory. And if they could be sealed, they were sealed with nitrogen gas and with valves on them, so our gauges, so we knew when it got shipped here that it was still tight, and anything that wasn't was repaired and retested. But that's how we mitigate our risk, was having everything tested at 3 times static pressure or the design pressure of the device.
But you do that in the field, but would you do that as a hydro at the site?
Well, we did in the factory. So say a coil comes to you, or in any unit that's contained, and it's charged with gas, and so it comes to us intact with the gas pressure on it. In the field, the system would be then installed, and after all the systems are installed, the field would be tested again as a total.
And your field test would be 150%, 100, or 300?
Well, that's a good question. So the field test would generally be 150%. We tested our electrical systems at 150% and our water systems at 150%.
Okay.
With a 300% design factor to them.
There's a lot more I'd like to talk to you about on this, John, but one thing I do appreciate what you're bringing out is, number one, that you did do a kind of a cost benefit analysis. You looked at the concept of, how much is it worth putting a diaper on something versus what is the damage going to cost? And obviously you get back to the people that do lease property data centers, and it ends up that their SLA may actually give some dictation here, and trying to give them some guidance is where we're going. Let's go back to those valves. Valves generally are not guaranteed for the life of a data center. Do you plan on them? How do you plan around the lifespan of a valve?
So you generally would have a configuration, hopefully, well, may or may not have configuration of N+1, but if you have a single valve that can shut down your system, you probably want to put some kind of bypass loop on it. That would be the most practical way, although if you don't have an N+1. But we did use bypass loops in those critical areas.
So the phrase concurrent maintainability around valves and stuff like that, is looking at the comparing a lifespan or getting a 10-year warranty versus most valves come, I think, default with a 1-year warranty. You can get them with a 10-year warranty. Is it worth dictating a 10-year?
Well, the gap is back to assembly, is that the valves may or may not fail because of packing, but you have the other issues of flow rates through the piping system, and if you're going to get any turbulence or erosion and cause some other difficulties around that valve, because you could identify a packing issue or a leaking valve visually. But the bigger gap was the actual installation, in that we didn't have turbulence or any erosion going on, or collection of, well, we didn't have chemical issues because we had very clean water. But the valve is an issue. You could specify that, but to the comments on this call already, the mean time to failure in the piping systems is really not manageable. The valve, you could buy a higher quality valve, particularly around the material science. Make sure you have compatible materials.
Real quick to interrupt, we're at the 4-minute warning.
Yeah. So,
and one question for John. I'm sorry, John, that was just talking from Intel. If you did nitrogen fill on a spool and it was arriving on site, what would you consider to be a pass-fail criterion there?
So we would adjust for temperature, ambient temperature, so it'd have to be plus or minus a couple pounds, because the thing could be sitting out on the cold dock or a warm day. But we try and take the temperature in the same. In other words, we specify factory loaded at 70 degrees Fahrenheit, whatever it is. That'd be part of the checklist.
A couple pounds of pressure is always your criterion. Okay.
Yeah, thank you. Exactly. Because most of that having to do with ambient influence on it.
Okay.
So
a lot of deep discussion coming on here. I'm trying to figure out how we can, we'll be talking about this topic again in 2 weeks. Next week, we're going back to the topic of reference design and the flow chart that Jason was mentioning earlier. Anyone else have comments right now? We got a couple minutes left.
Yeah, Don, this is Patrick Gingrosso. One of the questions was around just along this lines of 3 times system pressure. I mean, I think it's also good to understand what the system pressure actually is, low pressure versus a high pressure system. And, what does a leak look like in the system when you do have one, or if you ever get one?
Yeah, the 3 times. So the water systems on the coil side, on the work side in the data center was around, we were probably running about 75 PSI, but they were designed to 125. So we were testing between 300 and 400 PSI on that work.
What size pipe are you dealing with on these shipped and packed in nitrogen?
So those were in 2 to 3 inch category. Those are the coils, cooling coils were manifolded. Cooling coils had a capacity of about 500 kilowatts a coil and ran 150 GPM through them. And then the downstream of that would have been 2 inch flex connectors or flex pipe that was what made in the field. So for example, on the flex pipe, we had the factory test the entire roll at 3x the design, and then we took that roll and put that into production, had ends soldered onto it and soldered onto them, and then those lines were tested also. So we didn't end up with a bad roll from the factory.
Okay. Okay, I see we're right at the hour right now. I'm very interested in people that would like to put together some sort of written document, kind of consolidating a lot of what we're talking about, seeing if we can move forward in an area of recommending this specifications. And we're probably need to chunk that down into little bits and pieces. But if you're one of those people, there's nothing that would like to participate and help author something, please let us know. We'll still continue to have these calls, but the calls are a mixture of education as well as progress, and we would like to have a deliverable. So again, next week, the topic is, John, you want to kind of pitch yourself for next week? John Minash?
Yeah, we're going to continue going over that the chart that I had started. On that topic, by the way, if anyone on the call has access to and can provide the values and the nominal pipe sizes that we should include in there from the ASHRAE 90.1 table that John Gross had brought up last call, but in SI units, I don't have a copy of the SI, I have the IP. If anybody here has it, please give me a call or send me an email, and I'll get the proper citation into the chart and add those values in. So thank you.
Okay. Hey, appreciate the attendance. Look forward to next week's call. I think it'll be pretty good.
Thank you.
Thanks, Don.
Thanks, Don.